data science, and it's a very critical part of data science. Okay, so if you go into this exploratory data analysis in the book, it will list what are all the main theme behind when doing exploratory data analysis. Okay, so before giving you an idea of what it is, we will go over the traditional housekeeping, importing the Haynes dataset. We would be working with the Haynes dataset today. Okay, and this is the standard thing. We import the dataset, change the labels, and the factor age groups and the rest of the stuffs, right? So once we have it, we have this structure in here. All right. So EDA is in general, it's an informal procedure. There is no strict guidelines on what an EDA constitutes, but in general, asking questions about the data and trying to find answers, right, by visualizing, transforming, and modeling the data. So these constitute the EDA part of data science, right? And we can use the information to pose new questions, right? For instance, last time we saw that we did a transformation and we saw lots of new variables that you can create, and these new variables that you create will generate a lot more questions. So in general, EDA is these set of procedures that you iterate over and over again to get a sense of your data, right? So this is very critical, and that's why today is a workshop. You have to reproduce what's the kind of things that's going in there in today and the next workshop, right? So basically, if you we have to load the type library, the tidyverse library, right? So visualizing variations, as soon as you have the data, right? When you have a data, immediately you will have a variation in the data. That variation could be of several types, and it could be even the same. Like if you repeatedly take another measurement, you are anyway going to get an error, or it could be even a different instrument. Like for instance, you are running an RNA-seq on one machine, and on another machine, if you run, you will have the batch effects, right? So these are the things that are that cause variations within the data set, right? And there are always ways to visualize the distributions, right? And these variations are the source of your distribution, right? Data is a distribution, right? How many times a particular value appears, right? You can think of that as a distribution. And there are essentially two types of distributions depending on how your variable is. Either it could be a continuous variable or it could be a categorical variable. Categorical variable will have a fixed set of values, right? Continuous can take a range of values. So let's say that here I'm going to use the Haynes, and then I want to look at you can use for categorical variable, you can use the geom bar, which is a bar plot you can plot a bar chart, right, of using this geom. And this is like the diabetes. I'm listing the distribution of people with diabetes, right? And you have this distribution. So we can immediately you can see that the people who have no diabetes are much highly represented in the population, right? When the rest of these two people. And you can actually look at these values by what is known as a count function. So you can use the count function. You can manually find the counts, Haynes, and you can count the people with diabetes, and it's going to immediately give us a table with what's the values in there, right? For instance, for continuous variables, what you do is you use a histogram. So this histogram plots the continuous variables. So for instance, here I am plotting the glucose levels, right? And you can, for continuous variables, you don't have to really choose the bins, right? I mean, initially the algorithm optimizes the ggplot algorithm optimizes and chooses the correct size bin size that you may want to do here. And also you can plot multiple histograms, not just one histogram. You can plot multiple histograms and color them, and so that you can visualize them how the distribution looks like. For instance, I'm here using this glucose levels for different age groups, and this geom is given by geom freak poly. Okay, so the freak poly is going to give you the distribution according to age groups. Okay, so generally when you plot these distribution, right, you may want to see infer something from the data, right? I mean, that's done through looking at it and looking at the typical values, right, common values, and see how these how the data behaves, right? So, for instance, you may see that the distribution here, right? I mean, from 300, there are really absolutely almost no people who have glucose levels or higher than 300, right? I mean, so these are some of the insight that you can infer from the data from these distributions, right? So we can turn these information into useful questions. So what values are the most common, right? Why are they common and why are they typical, right? And which values are rare, and what, I mean, does it match your expectations of what you expect out of your data, right? Can we see unusual patterns, and what might explain them? These are the questions that you need to ask whenever you are working with your data set. So, for instance, this histogram below here, right? Here, if you look at the freak poly, this levels of HDL according to the health status. So, there are 5 health status: excellent, very good, good, fair, and poor. And I'm plotting the HDL for these, right? So, one of the interesting observation that if you see for the poor health, right, for people with poor health, right, the mean HDL is almost lesser than the rest of the stuff, and why is that, right? So this is a question that you may want to proceed, and you may want to find out, digging the data deeper on why this is the case, or even looking at the literature, right? So for instance, here consider this. I am plotting the log of UACR values with the age group, right? And you have the age group here, and you have the log of UACR values, and you see this is a bimodal distribution, right? So bimodality suggests that there are subgroups in the data, right? There is already 2 subgroups in the data, and so to understand these subgroups, we can ask these questions: how are the observation within each cluster similar to each other in terms of other variables? Is there any other variable that under this cluster they form together as a group, right? And how are these separate clusters different from each other in terms of other variables? And do the clusters have biological significance, right? Is there any biological significance behind these clusters? And why might these appearance of clusters may be misleading, right? Could be a batch effect, could be some other thing. I mean, you might have plotted it error. I mean, so there could be lots of errors that could lead to these kinds of distributions. But these are the things that we need to be looking at it. Maybe the people who are taken this UACR on one day, and there are other people who have taken in the other way, and and the standardization error could have happened. There are so many reasons why there could be bimodality, right? So that could be examined. Unusual values. So in general, this is also one of the important aspect of data science, doing an exploratory data science. When you do it, you are bound to see some outliers, and the outliers need not necessarily be, I mean, non-normal. That could be an exciting thing that's there in the outlier, right? I mean, you have to chase the outlier sometimes, and these are difficult to see initially, right? For instance, I'm taking the distribution of the creatine variable from this data set, right, and plotting it, and you see this. Now, as such, you don't see anything different, right? We can hardly spot any outlier, right? But if you change the axis, right, if you zoom it, and I'm limiting the axis only in this small range, right, 0 to 0.5, you see that there is something that's standing out separately here. So this is the kind of thing that may not be immediately or apparently known from the general plotting, but if you zoom in enough, if you play with the data a little bit, you may see and spot these outliers. And especially we can query this, right, using the data transformation. So what I'm doing is, once I'm looking at it, I have an outlier here, and the value is around 3.75 to 4.2, right? So here, and you can immediately query this. So you can take the Haynes data set, filter for these variables, and select the key and gender, and then plot it, right? So once you do it, I see that it's all females here. Is there a standard outlier? Is there anything key in here? mean, those things needs to be chased, right? So I mean, these are the things that are important for doing data science and for analysis, and these questions are important. So for every plot that you see, you have to dig in deeper and see. It's not just that, okay, so I have a plot and I have a homework or I have a project, but the more detail that you put into your work, it's going to pay rewards either in your this course or later, when in your career. So it's very important to do that. So chase each and every detail to understand why you see the things that you see. Okay. So with that, it's a very small lecture today. But what I want you to do is, these are the same things that is available in the in the book, but it's given for the diamonds data set. Okay, so I have just reproduced this in terms of the health data set. Okay, so what I want you to do today is take your data set of your choice. It doesn't matter, I mean, except for the same thing, you may not want to just repeat what I did here, right? So I don't want you to repeat this. Take the data set of your choice and follow it through. So the whole exploratory data analysis is going to be in your data set. Okay, finally you may turn this data set as your project too. Okay, or you may want to just play with some other data set. That's fine, but you are going to take your data set and do some exploratory data analysis. Okay, just reproduce. Here they have given it for the diamonds data set, but you're going to do it for your own data set, just like how I did for the Haynes data set here. Okay, you can take Mimic3 or you can take any other data sets that's available for you. All right, so with that, I'm going to be here. So if you're having questions, I'll be happy to troubleshoot, and we can work through. All right, so that's the class for today. It's short, but I want you to work and know your data sets better. All right, so that's the key.